Voyager 1, the most successful probe of all time, returned after a dramatic event. Now returning data from all four instruments, the mission continues as Voyager 1 plunges deep into interstellar space, providing us with unprecedented impressions of the outer surface of our solar system. But what actually happened? Why did the probe send out junk for almost half a year, and by what genius was Voyager 1 repaired? Voyager 1 was presumed lost. The position of the probe was still relatively clear, but the data was unusable as of the fall of 2023. The NASA Command Center in Pasadena received only cryptic messages consisting of firsts and timets that made no sense. The team fought for months to save the probe. Then came the sad day when NASA announced that Voyager 1's mission was probably over. What a joy it was when just a few weeks later it was announced that the probe had been returned. In the fall of 2023, Voyager 1 began sending incomprehensible data to Earth. Communications, which had worked almost flawlessly since the operation was launched in 1977, were suddenly cut off. NASA scientists and engineers were at a loss for months. Paralato told NASA engineers that the spacecraft's scientific instruments were still working, but the data they were receiving could no longer be interpreted. This caused great concern. More than 20 billion kilometers from Earth, the probe is an indispensable tool. Never before had a probe transmitted data from interstellar space. Of course, NASA has done everything possible to get this space exploration veteran back to work. Experts tried to decipher the sensor messages to draw conclusions about the error, but even the most skilled technicians and decoding experts came up with nothing at first. Then came the first breakthrough. A Deep Space Network researcher monitoring the probe's communications managed to read the message for the first time. Voyager 1 permanently transmitted a perfect copy of its memory and control system. This was good news because these systems are like the heart and brain of a sensor. So Voyager 1 was alive, but the way the data was transmitted was unclear. Despite this understanding, it was difficult to keep up with problems. The biggest problem was the distance between Voyager 1 and Earth. It takes more than 22 hours for radio signals to travel in one direction. This meant that all the diagnostic procedures took almost 2 days to get an answer. Initially, engineers focused on the flight data subsystem, which is responsible for compressing and transmitting scientific data. Initial analysis indicated that a very specific chip for this subsystem might not be working properly. It took months of intensive testing and finding the exact cause. NASA engineers worked tirelessly to develop and test various solutions, but all failed. For a while, it seemed that all options had been exhausted, and concerns grew that Voyager 1 might fall silent after nearly 5 decades of faithful service. The morale of the crew was low, and the prospect of losing humanity to its most distant cosmic emissary was hard to bear. Millions of SON fans around the world were feverishly waiting for the news. NASA kept scientists and space enthusiasts informed, published companies, shared progress and publicly acknowledged disappointments. In February 2024, NASA's mission manager announced in a public statement that the mission was slowly coming to an end. There was great sadness, but there was also hope. Despite setbacks, some engineers did not give up. Advice and ideas to bring Voyager to life continued to flow in from across the country and from experts around the world. NASA decided to follow an interesting new approach. The idea was actually simple: the faulty code was directed to another part of the SDS. This was not without risk, as it could mean permanent radio silence. The process required precise coordination and timing. Every signal sent to Voyager 1 had to be carefully tuned to prevent further damage. On April 20, 2024, the unthinkable finally happened. After months of effort and countless hours of hard work and dedication, Voyager 1 once again sent intelligible data to Earth. Can you imagine NASA's joy and jubilation when the information made sense again? And it got even better: all 4 of the spacecraft's scientific instruments, which are still important, were fully functional again. This victory once again elevated the Voyager 1 mission into the ranks of absolute space legends. Reconnecting with Voyager 1 was not only a technical success, but also an emotional one. All participating scientists and engineers from around the world were delighted. After the problems in 2021 and 2022, this was the second successful repair of the probe, which has been in space for more than 45 years, more than 20 billion kilometers away. Voyager 1's story continues, and who knows what other secrets interstellar space holds for us. Incredibly, this probe can continue to transmit data for another 10 years. The batteries will probably fail for good by the mid-2030s. After successfully resuming its mission in April 2024, Voyager 1 is now back at the center of interstellar exploration. The spacecraft has already provided historical information about the outer planets and frontier regions of our solar system. Now it penetrates deeper and deeper into the endless space of interstellar space and explores unknown regions. Scientific goals and expectations relate to the measurement of particles from interstellar space and the study of cosmic rays and magnetic fields. This information helps scientists better understand the structure and composition of space beyond the heliosphere. Our Sun surrounds itself and its planets in a protective bubble of particles and magnetic fields. Behind this bubble begins a completely different space. Plasma waves are particularly interesting. These waves should give us information about the density and motion of the interstellar medium and help us understand the entire universe a little better. Since Voyager 1 is the first probe to explore this region, the information obtained will be invaluable in astrophysics. After all, this medium makes up most of the galaxy. Beyond the boundaries of our Milky Way begins an even wider intergalactic space. We don't know what really happens in interstellar space. All information that has reached us is based on estimates, calculations and assumptions. Science has confirmed some of these assumptions, but others have been proven completely wrong. Voyager 1 has proven this once before when it crossed from the heliosphere into interstellar space. Scientists imagined that the threshold was quite different, and interstellar space also surprised them with a higher than expected density of particles and an undefined plasma flow. Who knows, Voyager 1 might find evidence of previously unknown objects or even exotic forms of matter. Such discoveries could have a revolutionary effect on our understanding of the cosmos. One particularly exciting possibility, of course, is finding traces of extraterrestrial technology or signals. It is certain that Voyager will continue to fly for hundreds of thousands or millions of years after the end of radio communication. Should the probe ever encounter other intelligent civilizations, it and its twin, Voyager 2, have a golden record of greetings from humanity. When and if these messages will reach other life forms is truly written in the stars. It will take Voyager 1 a full 40,000 years to approach the nearest star, B445. Can you imagine how long the information and achievements of the Voyager mission have been with us humans? Many of you probably weren't even born when this probe was launched. Generations of scientists worked on the exciting discoveries of Voyager 1 and 2. In honor of this extraordinary mission, we look back at its greatest achievements. In 1977 Voyager 1 was launched from the Cape Canaveral spaceport in Florida. After several flybys and passing through the asteroid belt, the probe reached the gas giant Jupiter in 1979. Voyager 1 analyzed the upper layers of Jupiter and took detailed images of the marble surface and the Great Red Spot. Later, Saturn stopped the probe. The flyby revealed the complex structure of Saturn's rings and Titan's atmosphere. Voyager 1 then began its journey to the edge of the solar system, while Voyager 2, after its first trip to Jupiter and Saturn, visited the outer planets Uranus and Neptune. One of the most iconic images in the history of space exploration was taken from 6 billion kilometers away. Voyager 1 took a farewell image of Earth as a pale blue dot. That was in 1991. Then there were almost 20 years of silence around Voyager. Most of the equipment was turned off to save energy, and the probe was guided through the Kuiper belt and ever closer to the edge of the solar system, to the end of the heliosphere. NASA restarted the instruments and Voyager 1 returned to report data. Scientists wanted to know what the magical threshold is between our solar sphere and interstellar space. In 2012, the time finally came, and Voyager reported an amazing jerky transition that was completely unexpected. This showed that our Sun accumulates a threshold of a type of solid particles at the boundary of its sphere of influence, which acts as a thick protective skin. So far, we have received data from interstellar space for 12 years. 4 instruments continue to operate. Voyager 1 uses its plasma wave instrument to measure the density and temperature of charged particles, which are rarer in the interstellar medium than in the solar system, but have completely different charges and probably different physical properties. The cosmic ray instrument detects high-energy cosmic rays to analyze their composition and, above all, their origin. For example, strange rays can provide clues about objects or structures that we may not have seen before because they are in complete darkness. A magnetometer, which measures the strength and direction of the interstellar magnetic field, can also provide us with such clues. The sensor also detects low-energy particles using a particle detector. This is important for determining whether interactions between the solar wind and the interstellar medium can be found even further out in space.